Okay, you guys, so today we're going to go over limits at infinity and horizontal asymptotes. So the first thing we need is a definition. The limit as x approaches infinity plus or minus infinity of f of x is equal to L means that the values of f of x can be made arbitrarily close to L by making x a very large positive or negative number, okay? So what this means is that basically as x becomes very, very, very large or approaches a very, very large number or a very, very large negative number, then if they approach this particular number, we get to say that it is L, okay? So in this case, and I want to warn you again that infinity is not a number that you can do arithmetic with. So you can't do you can't do, so let me put this over here. Be careful. Well, let's do this. So you cannot do stuff like this. You cannot do the cosine of infinity. You can't do that. You cannot do infinity cubed minus infinity. You can't do that. You can't do f of infinity. You can't do that, so on and so on and so on. Can't do these things because that's you treating infinity like it's a number that you can just do basic arithmetic with. It just doesn't work like that because remember, infinity is an idea of the biggest number there is. So you can't really, it's a concept. So you can't plug it in per se like that. So that's kind of why we have the notation of limits. Limits is what allows us to work with infinity so easily and kind of do calculations with infinity because limits, you don't actually reach the number either. So that fits perfectly with infinity. So when we come over here and we work with problems like this, we say the limit as x approaches infinity of x cubed. What they're saying is if you take a really, really big number and you cube it, it's going to be a really, really big number. So this would still become infinity, okay? You don't put infinity cubed, it's just infinity. Sometimes in our minds, we like to do this. We like to say, oh, well, this is infinity cubed, which is infinity. And that's kind of the idea behind it. But what we're honestly doing is we're saying if x is approaching a very large number and then we cube it, then it should be approaching an even larger number, which is still approaching infinity. So we don't actually plug it in, but sometimes in our minds we do, or if you're trying to explain yourself, you kind of write it down that way. But in general, if you're not working with limits, you really can't plug infinity into anything and you can't even talk about it. So notice over here, there are no limits attached to any of these. So you got to be real careful trying to do arithmetic with infinity. Now, if you take a number like e, the natural number, and you raise it to the power of x when x is approaching infinity, well, wouldn't that just be some number to a really, really, really big power? Well, that's just going to be a really, really big number. So we say that's infinity. And now this one, as x approaches infinity of 1 over x. Now think about this. If you took $1 and you split it amongst 10 people, right, you would get 0.1. Now let's say you took $1 and you split it amongst 100 people, you'd get 0.01. Now let's say you took $1 and you split it amongst this, and I'll just put an exaggerated number of zeros. Well, then you would get 0.00000000001, right? So you're getting smaller and smaller value as your denominator becomes larger and larger. Well, what is this number approaching? 0.00001. Isn't that getting really close to zero? Now, it'll never make it to zero, but if you have the limit as x approaches an infinitely large number, then we can approach zero ourselves. So we get to say that the limit is in fact zero. So this one is a huge one. This one we're going to work with all the time. 1 over x, 1 over x squared, 1 over x cubed. They're all going to become zero. So this is just kind of something you guys really want to keep in your mind, that this will help us clean up. This problem right here helps clean up a lot of problems. And I shouldn't say that particular one, but that concept of a constant divided by an infinitely large number, okay? So now let's go over to here. So what I would like to do is I would like to evaluate the limit as x approaches infinity of 2x squared over x squared plus 1, okay? Now we did a problem similar to this in our previous, classes in, what's it called, in pre-calculus, or if you had another pre-calculus instructor. Your instructor probably didn't use limits per se, but the idea as x gets really, really large, what happens to this function right here? What's going to happen to this? So that's something we're interested in. And you guys already know that, oh, this limit would be 2 because there was a formula or a set of rules that you memorized that said, you know, if the power, the dominating term in the numerator and the dominating term in the denominator are the same power, then you can just take the leading coefficients and divide them. So you would just do 2 over 1. Oops. You guys would just do 2 over 1, which is 2. But you never actually did anything with limits. You just memorized a rule. So for us, I'm not going to let you do that for a while until, you know, towards the end of the semester. I'm going to require you to kind of show that you know how to do this. So what we're going to do is we're going to factor. We're going to take the limit as x approaches infinity of 2x squared over x squared plus 1. And I'm going to rewrite this limit as x approaches infinity. And I'm going to factor out an x squared. So kind of the idea behind it is whatever the biggest power in the denominator is, you divide everything and factor that out. So I'm going to divide this by x squared, I'm going to divide this by x squared, and I'm going to divide that by x squared. So when I do that, I end up with 2 over 1 plus 1 over x squared, right? Because these will cancel and become 1, these will cancel and become 1, and then this will stay 1 over x squared. So that's what I have now. So now, when I go to plug this limit in, remember, we're allowed to take the limit of these different pieces. So I'm not going to go through and write it out, but you could take the limit of 2, you could take the limit of 1, and you could take the limit of this as 3 separate entities. But the idea is that we're going to take x approaching an infinitely large number. Well, that's kind of similar to this idea once again right here of 1 over x as x approaches infinitely large. Well, this is 1 over x squared as x approaches infinitely large. Well, if you take $1, right, and you divide it by an infinitely large number, you're going to get 0. So I end up with 2 over 1 plus 0, which is just 2. And that would be our answer for this problem. Okay, so that's how you guys can work with rational functions. So this works very well with rational functions. So with rational functions, this idea of dividing by the largest power in the denominator, the largest dominating term, then it can really help us clean it up instead of just using our memorized rules from pre-calculus. Okay, so let's take a look at another problem. Okay, now let's look at something a little bit bigger. Let's evaluate the limit as x approaches infinity of 5x squared minus 3x plus 1 all over 7x to the 4th plus 2x plus 3, okay? So what I'm going to do is I'm going to do the same thing as before. So limit as x approaches infinity, and I'm going to divide every term by x to the 4th. And this is only legal because I'm doing it to every single term, okay? So this will now become 5 over x squared minus 3 over x cubed plus 1 over x to the 4th divided by 7 plus 2 over x cubed plus 3 over x to the 4th. Now again, I could have from the very beginning tried to just plug or think about infinity in each one of these. Think about each one of these with infinity, but what I would end up with is something like infinity over infinity or infinity minus infinity over infinity. And none of that is acceptable. We're not really allowed to work with that. So we normally have to do something like this or some other algebra technique to simplify these problems. So now what I'm going to do is, well, I know that I'm approaching infinity, right? So this is going to become 0. 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 And I'll be left with 7. So I end up with 0 over 7, which is 0. So my limit as x approaches infinity of 5x squared minus 3x plus 1 divided by 7x to the 4 plus 2x plus 3 is 0. So you have to show me this step here and this step here, okay? Again, that's in the beginning of the semester. As we get closer to the end of the year, you'll be allowed to kind of cut out some of those steps once we get into L'Hopital's and stuff. And especially those of you that move on to take me for calculus 2, you would do something similar. So the thing is we get 0, okay? So I want to write out some of what we've been doing here. Oops, I want to write out some ideas. So it says if r is greater than 0 is a rational number then the limit as x approaches infinity of 1 over x to the r equals 0. So that's what we just did in the previous problem. If r is greater than 0 is a rational number such that, oops, x to the r is defined for all x, then the limit as x approaches negative infinity of 1 over x to the r is equal to 0. So basically saying whether it's negative infinity or positive infinity, if it's, you know, a constant divided by an infinitely large positive or negative number, even if it's to a power, it's still going to become 0, okay? Let's see here. So if p of x and q of x, if p of x and q of x are polynomials, then to evaluate the limit as x approaches plus or minus infinity of p of x over q of x, we divide, and this is just what we did in the previous problem, the numerator and denominator by the highest power of x in the denominator. So this is just putting into words what we just did in the denominator. Okay, so that's all. I just wanted to put into words what we just did in that previous problem. So let's take a look at another one. Oh no, and then I want to say so whenever you're taking all of these limits at infinity, what you actually are finding is horizontal asymptotes. So it says the line, let me write this up actually in red, this is really important, okay? The line y equals L is a horizontal asymptote of y equals f of x if either of these following things happen, okay? If the limit as x approaches infinity of f of x equals L, or the limit as x approaches negative infinity of f of x equals L. Okay, so basically saying if you take a limit as x approaches infinity or negative infinity and you get an actual answer, then whatever the limit that you actually get is your horizontal asymptote. So this limit that you actually get right here would end up becoming your horizontal asymptote. So that's why they say the line y equals L, okay? So whatever you get for these limits, that will be your horizontal asymptote, okay? So let's take a look at this. So that's kind of like math code when they say find the horizontal asymptote. You know, that's math code for, hey, take the limit at infinity, okay? So let's take a look at something a little bit harder. So it says find the horizontal asymptote or asymptotes for f of x equals, and now we're going to do a square root of 9x squared plus 2 all over 4x plus 3, okay? So now here's the thing. When we're dealing with these problems, we have to be a little bit careful because this is a square root of 9x squared plus 2. This is different than just some polynomial divided by a polynomial, all right? So we got to be a little bit more careful. So with rational functions, it's usually, you know, there's only the one horizontal asymptote. You know, you can get vertical, horizontal, or slant asymptotes. But with other types of functions, you have to be a little bit more careful. So what I'm going to do first is I'm going to show you the harder one, okay? So we're going to go from positive infinity and we're going to go from negative infinity. So the first one I'm going to do is negative infinity because it's a little bit harder, okay? So I'm going to do the limit as x approaches negative infinity of 9x squared plus 2 divided by 4x plus 3. Okay, so we're going to take this limit. Now, nobody in the problem told us to take the limit as x approaches negative infinity and positive infinity. Nobody told us that. But the thing is that if they ask you for a horizontal asymptote, whenever you are asked for a horizontal asymptote, this implies find limits at infinity. So that's what it's implying, okay? So what we have to do is the first thing we got to figure out is how we're going to deal with this negative infinity and, you know, dividing by a power. So we're going to employ a similar technique we used before. We're going to divide by our highest power in our denominator. So this is going to become the limit as x approaches negative infinity. And I'm going to divide 9x squared plus 2. And I'm going to divide it by x. And then this is all divided by 4x plus 3. And I'm going to divide this by x. Okay? So now let's see what we got. So we have the limit as x approaches negative infinity. Now the problem is I cannot get, this is an x and this is a 9x squared inside of a radical. So I can't actually get inside there unless I do something different, okay? So what I'm gonna do is I'm gonna say, well, how could I get this x right here to interact with this square root? Well, the only way that square roots can go together with other, I guess, how do I say it, other functions is if they're both, I don't want to say go together, but I would like to be able to combine them under one radical. So in order to do that, I have to rewrite this as square root of 9x squared plus 2, but it has to still be worth the same. I can't change the value. And notice this is legal because dividing by x over x is really the same as dividing by 1 or multiplying by 1, whatever helps you think about it. So I'm going to change this to the square root of x squared divided by 4x over x plus 3 over x. So I just basically, just to let you guys know, I split this like this, and then I rewrote this as square root of x squared. Now, what is square root of x squared? It's just x. So I've literally done nothing. I haven't changed the problem at all. So now I'm going to have the limit as x approaches negative infinity. Now I can rewrite this as 9x squared plus 2 over x squared. Remember, this is the quotient property for radicals. So I use the quotient property for radicals to write them as one house, one radical together. And then this will become 4 plus 3 over x. So if you notice, I'm totally fine with my denominator right now. My denominator is looking good. What I'm worried about is my numerator. So let's clean that up a little bit. So limit as x approaches negative infinity. Now this will become the square root of 9 plus 2 over x squared divided by 4 plus 3 over x. And some of these steps are unnecessary. I'm just trying to show you guys all the work so we can talk about it in class. So we have 9 plus 2 over x squared. Now the thing is we know that this is going to cancel and become 0. This is going to cancel and become 0. So what I'm going to be left with is the square root of 9 over 4, but that's actually 3 over 4. But there's actually a mistake here. Something's wrong. Now think about this for a second, okay? We're taking the limit as x approaches negative infinity. So that means we're dealing with an extremely large negative number, right? So somewhere in here, I made a mistake. I forgot to take this into account, okay? So we have to understand that when I converted this to x squared, the square root of x squared, that means that all the negatives will always still become positives because you're squaring them. But that can't be true in order for this to work. Think about this. What does this always have to be right in front? What always has to be in front of, or I'm sorry, if x is approaching an infinitely large negative number, right? That means this right here is always going to be positive. So the numerator will always be positive, right? But when I plug an infinitely large number in here, the denominator is going to become negative. So I'm going to end up with a positive over a negative, okay, always when I'm approaching a very large negative number. No matter what happens, in order for this to work, I'm going to be approaching a very large negative number, and it will cause my fraction to be a positive over a negative. But look at my fraction here. It's just a positive. So I lost something in this problem. When I tried to use my little technique of rewriting x and the square root of x squared, you know, I kind of, well, I guess from the beginning, I kind of forgot what we're actually approaching all along. We're heading in the negative direction towards negative infinity, right, on the number line. So we have to account for the fact that all the x's we're going to be, you know, using to evaluate will be approaching negative infinity. So what I needed to do is I needed to put a negative here for the remainder of the problem. Okay, so you have to think from the beginning, this is going to be a positive over a negative. So my final answer must be negative. There's also, you know, you can talk about the square root of x squared being the absolute value of x. So you have to worry about the plus and the minus version as well. So let's come over here and let's look at the limit as x approaches positive infinity now. And everything will be the same, of square root of 9x squared plus 2 all over what was it, 4x plus 3. So now we have to do the other side of the horizontal asymptote, because this is not, you know, a normal rational function. There was a square root involved, so we're going to have to clean this up. So this is going to become limit as x, I'm sorry, we're going to have to use plus and minus infinity. Sometimes you can just use positive or negative infinity. I feel that if you're working with rational functions, but things that are not rational functions, you normally should be doing the plus and the minus infinity. So we have, let's see here, same technique I used before. So this is going to be 9x squared plus 2 over x squared, right? I'm skipping right to this step, you guys. And then this will be 4x plus 3 divided by x. So then we're going to have the limit as x approaches positive infinity. But now there's not going to be any problems like there were last time. This is going to be the square root of 9 plus 2 over x squared, all divided by 4 plus 3 over x. And I don't have to worry about a negative because this is always approaching a positive, right? And this is always approaching a positive because we're approaching x as a positive. So I can just write, this will be 3 over 4. And that will be my other horizontal asymptote. So down here, I'm going to say my horizontal asymptotes are y equals negative 3/4 and y equals 3/4. So you must name your horizontal asymptotes. Okay, so that is how you can do a slightly harder problem working with horizontal asymptotes. Now let's look at a few practice problems. Let's see here. How do I want to do this one? Well, this one looks tough. Let's take a look at this. This is just some examples, practice problems. Okay, so let's say we have the limit as x approaches infinity of x minus the square root of x squared plus 2x, okay? Now, if we try to plug infinity into this, we would get infinity minus infinity, and that is not 0. We don't know what that's actually going to be. I mean, I guess it could be 0, but we don't know for sure. This is something that we're not going to deal with. We don't want to have to mess with that. So we want to do some fixing. So what I'm going to do is I'm going to use some algebra. And in general, when you see a plus or a minus sign with a square root and then some other term, what we're going to do is we're going to multiply by the conjugate. Doesn't always work, but it's kind of a good go-to move for you to kind of get started. And a lot of times this helps us clean up our problem, okay? So then this will become the limit as x approaches infinity. And again, I think you guys should pause the video right here and see how far you can go. And then unpause it and see if you get to the same spot as me. Okay, so hopefully you guys foiled this out. Remember, you got to do all this foiling like this and then like this. So let's see what we get. We get x squared minus x squared plus 2x, all divided by x plus square root of x squared plus 2x. Let's see what this equals. And again, I don't know what's going to happen per se. I just know this is kind of my go-to technique. The x squareds look like they're going to cancel, and I'm going to be left with negative 2x over x plus square root of x squared plus 2x. Okay. Well, there's a couple directions we can go from here. If I try to plug infinity in right now, once again, I get infinity over infinity, which is not good for us right now. We got to wait till chapter 4 point something, 4.4 if you're in the Stewart book. So what I'm going to do is I'm going to kind of use a technique of factoring that you guys may not be exposed to a lot, but it's something we want to get better at. I would really love to be able to cancel these x's out. So what I'm going to do is I'm going to factor out x squared from here. So this would be x squared times 1 plus 2 over x. And I know this is right because if I distribute this back in, I would get back to here. So this is not illegal to do. Now I can split the square root, right? And this could be the square root of x squared times the square root of 1 plus 2 over x, right? So this is a technique you can use with factoring to kind of show how you're developing your idea here. So I'm going to say the limit as x approaches infinity of negative 2x over x plus, now the square root of x squared is just x times the square root of 1 plus 2 over x. Now we're starting to get somewhere. So now we take the limit as x approaches infinity. Now notice I can factor in x from here, here, and here, right? So I'm going to take an x from each piece, and that's going to leave me with a 1. What I really did was factor the x out of the denominator and then cancel, but I'm running out of patience with this problem. So this becomes 1 plus the square root of 1 plus 2 over x. Now we can finally get somewhere. Now if I try to work with infinity, I know that this is going to become 0. We've been doing that quite a bit now. And this will become negative 2 over 1 plus the square root of 1, which is negative 2 over 2, which is negative 1. And we found our limit. So this is one of the harder variety in the class until we get to chapter 4. Then we'll find a different way to do this perhaps. But for now, this is all we got. This is a problem that we run into that idea of infinity minus infinity, and then we could even run into infinity over infinity. So these are all things we are trying to find ways out of, okay? So hopefully that gives you guys something to work on that one. What if I asked you guys to try the limit as x approaches, so evaluate, limit as x approaches, x plus 3, no, wrong way. Limit, evaluate, limit as x approaches infinity. Let's do negative infinity for this one. Negative infinity of 2x cubed minus 5 all over 3x squared plus x plus 2. So what I'm going to do is that technique I did before. I notice it's a polynomial divided by a polynomial. I'm going to divide by x squared, divide by x squared, divide by x squared, divide by x squared, divide by x squared to every single piece. So this will take me to the limit as x approaches negative infinity of 2 minus 5 over x squared divided by 3 plus 1 over x plus 2 over x squared. Now we use this idea that we learned in way up top, way up here. Where did I say? This one right here, right? It's still working with negative infinity, still gives us 0. So I now know that this will become 0, this will become 0, this will become 0. So we're going to be left with 2 over 3. Okay. So again, this is the value. Now notice they didn't ask me for the horizontal asymptote. If the problem had said, find the horizontal asymptotes, then I would have to follow it up with saying y equals -1 and y equals 2/3. Okay, but the problem did not ask for that, so I don't tell them the horizontal asymptote. Here, they specifically said, find the horizontal asymptotes, and then I knew that that meant find the limit at positive and negative infinity. So be sure you're on the lookout for when they ask for horizontal asymptotes, and then sometimes they just want you to find the limits like this, okay? That's gonna do it for this section, guys. I might have a practice problem for you. Actually, well, I'll try to find another one. Maybe I'll do it as an add-on to the next section. But that's gonna do it. This should get you started on horizontal asymptotes and limits at infinity. Thanks for watching.